Hello everyone, let's solve Leetcode problem number 100, same tree, right? So what the question says, given the roots of the two binary trees P and Q. So these are different binary trees, write a function to check if they are same or not. So they have asked us to write the function to check if they are same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So nodes should be having the same value as well as they have to be structurally identical. Nothing means they have to be exactly same, right? So nodes here in the example 1, we have these two trees are identical and the value of the root is same, 1 and 1, and the leaf nodes are also same. Left and right nodes are also same. 2 is equal to 2 and 3 is 3. So this what we are getting P1, 2, 3, Q1, 2, 3, the output will be true. If they are not structurally identical, then we are returning false. In this case, see, we have 1, 2. Here, the left node is 2. But in the second tree, we don't have left node. Left node is null, right? Basically here. But the right node is 2. Here, we don't have the right node at all. Here also, this is null basically. So, we are getting the output false. Same goes with the example 3 as well. So, they are identical, but the values are different here. If you can observe, 1, 1. Instead of 2, here, we have got 2 and 1, 1 and 2. These are, the values are different, so we are getting the output false. So, how can we achieve that? Let's see. So, what we'll do initially, just give me a second. Suppose, let's consider this example. What we can do, first edge case is if either P or Q is null. So suppose the value we have null, right? So suppose we consider this one as P. We don't have any value. And we will check whether either P or Q is null. So let's consider, so this one. We have null, we have nothing. Basically either one of these, P or Q is null. Then we will check whether P is equal to Q. We'll compare P is equal to Q. Why we are doing this one? If P is null, Q should be null as well, right? So that is the first edge case basically. If Q is null, P has to be null as well. So that we will check. This is the first edge case. The second one, what we are checking here is the values basically, right? So first one is, this one is P and this one is Q, right? P dot value, P dot val should be equal to Q dot val. Nothing but these two should be equal. And also we can make use of the recursion and we can check, we can recursively, what we can do, check if the current node values are of the both trees are equal. Nothing but this one and this one. Next, we recursively check the left subtree and the right subtree. How we can check? So P dot left is recursive function of P dot left and Q dot left, whether they are equal or not, and recursive function of P dot right and Q dot right. Basically, they are equal or not, we will be checking. So if they are not, if they are equal, we are returning true. If they are not equal, then we'll be returning false. So let's continue by writing the code. Just close this one. Let's start writing the code. First one, if either P or Q is null, right? So then we will check if both are null. So I'll just give if not of P, if P is undefined and if Q is undefined, then what we will do, as I have said, we will check both are undefined or not, right? This is the first edge case. Next, we will check if the current node values of both trees are equal. First, I'll just give return P dot val equals Q dot. Also, next, we'll just make use of the, we'll recursively check for the left subtree. How can we recursively check for the left subtree? I'll just make use of the function name. I'll copy here. We are checking for P dot left. Also, Q dot left. These two has to be same, right? And also, we will recursively check for the right subtree as well. So, here first, sorry, we have to mention the function name and p dot write as well as q dot. So let me format the code and let me hit the submit. So let's wait for some time. Yeah, this works completely nice. Completely good, right? So what will be the time complexity and the space complexity? The time complexity would be big of n. Why the time complexity is big of n? The function visits each node exactly once to compare the trees, right? Basically, I have showed that with the example. So, and also, what is the space complexity? The space complexity would be big of h. Why the space complexity would be big of h? Because we are making use of the recursion stack. So, we are making use of the recursion stack, right? So, here we can see it. So, h is nothing but the height of the tree. So, the time complexity would be big of n. Sorry, yeah. Here, the space complexity would be big of h. So, I'll just comment this one. So, yeah. So, what happened here? Let me hit the submit again. So, this is working fine, right? Yeah. So, yeah, this is it. Thanks for watching, guys.